Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which is helpful for your international entrance exam or else any competitive examination. And this is about JEE entrance exam like advanced and mains examination, NEET chemistry for medicinal entrance, and also helpful for Telangana and EAMCET, Telangana, Andhra Pradesh EAMCET examination. Apart from all these, it also will helpful for you regarding all the competitive examinations. So the content whatever covered in this are retrieved from the all previous year question papers, and detailed explanation is given to you that might be fetching for you to crack whatever you're aspiring for. So that let's enter into our today's concept. Question number 1. First of all, we are going with the IUPAC nomenclature question. Name the 2 organic compounds given below as per the IUPAC nomenclature, right? So here, one of the compound is given as a 6-membered ring with the 3 substituents over there. And second compound also benzene ring with the 3 substituents over there. And numbering is also provided to you 1, 2, 3, 4, right? Among all, here, if you see, second and fourth position are having chloro, so that we can say dichloro. And remaining this chain is said to be a phenol, so that we can say 2,4 dichlorophenol. And another is about at the second position we have bromo, fourth position we have methyl, right? So whenever bromo and methyl is there, we have to go for alphabetical order. B comes first over M. That's the reason why 2 bromo should be written first, followed by 4 methyl, and the parent ring will be benzoic acid, so that we can say 2 bromo 4 methyl benzoic acid. Let's see. 2,4 dichlorophenol is the IUPAC name of the compound one, and 2 bromo 4 methyl benzoic acid is the IUPAC name of compound number 2. This is regarding IUPAC nomenclature. Let's move on to question number 2. This is the question given from periodic table. In this periodic table, some numerals are provided in the blank periodic table. Here 3, 5, 6, 1, 2, 4, 7. And the question is, which 2 numbers are metals in the same period? Periods are the horizontal lines. Main groups are the vertical rows, right? So that if you see the period, in the first period, you can find element number 1 and element number 2. In the second period, you can find element number 3, element number 4. In the third period, you can find 5 and 6. And here, fourth period is having only one element, so that we can't suggest this only one element in the same period. Periods are always horizontal one only, horizontal rows only. So that either the possibility will be 1, 2, 3. 3 periods you can consider. So here, in general, we can say the elements whichever resided in this left hand side are said to be main group 1, main group 2 are said to be S block, and whatever elements resided in these are called P block. In between, you can find a D block, so that all the S block elements are metals only, so that we can say atom number 5, atom number 6 are having equal nature of metals. So it's very clear to confirm 5 and 6 numbers wherever present, that will be the combination of metals which resided in the third period. So that same period. This will be the correct explanation, right? And here also you can find 1, 2 on the same period, period number 1 itself. But the thing is, sorry, here in this period only they mentioned, but here atom number 1 and 2 are present in the P block. We can say P block elements are non-metals which are at the topmost, so that we can't say they are metals, right? And 3, 4. 3 is present in S block, metal. 4 is present in the P block, non-metal. So that we can say 3, 4 is also not right combination. The correct answer will be 5 and 6 atoms. So let's see. If you see the entire periodic table, first main group elements are said to be alkali metals. Second main group elements are said to be alkaline earth metals. So that the elements whichever present in the third period are the part of metals only, right? So third period, 5 and 6 elements are metals only. If you go with these P block elements, you can find a few metals few metals are at the bottom, and these are said to be non-metals, and these are said to be metalloids. And here you can find inert noble gases, and in between d block elements are there, which are transition elements. This is about the entire framework of periodic table. The correct explanation for the given question will be option number D. For question number 2, option number D will be the right answer. Let's move on to question number 3. Among the following, total number of species not having 8 electrons around the central atom in its outermost shell is: ammonia is given, aluminium trichloride, beryllium dichloride, carbon tetrachloride, phosphorus pentachloride. How many? 1, 2, 3, 4, 5. 5 compounds are provided among all. Which species are not having 8 electron system called octet system? Octet is not present in which compounds? So the correct answer will be 3. So among 5, 3 are not having octet configuration. Let's see how can we explain this. If you see Lewis structure of ammonia molecule, nitrogen is accompanied by 3 bonds and 1 lone pair. So that let me count. All 3 bonds contains 2 electrons in each bond. 2 plus 2, 4 plus 2, 6 plus 2, 2 electrons lone pairs existing on the nitrogen. So that we can say 2 plus 2, 4 plus 2, 6 plus 2, 8. So that octet satisfied with the 8 electron system. So ammonia is having 8 electrons. It may not be the correct answer. And if you see aluminium trichloride, aluminium surrounded with the 3 chlorines. So that let me count 2 electrons, 2 electrons, 2 electrons. So that aluminium surrounded with only 6 electrons. That's why octet not satisfied. There is no octet and only we have 6 electrons. 6 electrons means less than 8. 8 is the stable one. So less than 8 is called hypovalent. Hypovalent means less than the required one is called hypovalent. If you see the beryllium dichloride, beryllium surrounded with 1 bond one side, say 2 bonds second side. Linear molecule. Beryllium dichloride is a linear molecule with the 2 covalent bonds. So that we can say only 4 electrons are there. And no octet. Octet is not satisfied. So that we can say again hypovalent. So that less than required level hypovalent it will be. If you see the phosphorus pentachloride, phosphorus surrounded with 1, 2, 3, 4, 5. 5 shared bonds are there. Covalent bonds are there. 5 2s are 10. So that 10 outermost electrons are present around the phosphorus. And again we can say it is not obeying octet. Octet means only 8 required. But here we have one more extra bond to give 10 electron. So that this is a kind of hypervalent. Means more than required we have. Hypervalent. So among all, ammonia is having required. So AlCl3 is not having required, only 6 are there. So this is 1. Here beryllium dichloride 2, phosphorus pentachloride 3. So total 3 molecules are not having 8 pi electron system. So for question number 3, correct answer will be 3 molecules. Let's go with the question number 4. Which among the following molecules on polymerization produces neoprene? Neoprene is the polymer. It is the synthetic polymer. What is the monomer in order to synthesize? 1,3 butadiene is not possible. Bunion rubber, we can use this. In case of neoprene, chloro substituted 1,3 butadiene is the suitable answer. We can say 2-chloro 1,3 butadiene is the monomer in order to synthesize a neoprene. So let's see how can we produce. Chloroprene is the starting material. So here chloroprene can be treated. It can be polymerized so that a neoprene polymer formation is possible. You can see neoprene polymer, right? So for question number 4, option number 2 will be the correct answer. Let's move on to question number 5. It is a question given from what we can say ideal gas, so that it is the gaseous state of the chemistry. So in that 10 liters of ideal gas of pressure 5 atmosphere expands isothermally and reversibly to the final volume of 100 liters. Initial volume of the gas, ideal gas is 10 liters, final volume is 100 liters. The work done and heat absorbed in this process, liters atmosphere respectively, right? So here, two parameters to be depicted over here. One of the parameter is how much work done, and second parameter is what is the amount of heat absorbed, right? So the correct answer will be work done is minus 115.15, then heat absorbed will be 115.15, right? So this is the way we can answer. Let's see how can we solve this problem, right? In order to get the values, first of all, ideal gas equation PV is equal to nRT. So where we are having RT is equal to, let's assume N1, R1, T1. Okay, let's take the initial values. So initial pressure is given as 5 atmospheres and initial volume is given as 10 liters. 5 atmospheric pressure, 10 liters. Moreover, N value is 1. If you consider N value is equal to 1, so that RT is equal to 5 multiplied with 10. So the value will become 15. Okay, this is the value of RT. R is the gas constant, T is the temperature on Kelvin scale, right? So this is the way we can solve. So after getting this one, the formula for work done is equal to negative 2.303 RT log of volume final divided with volume initial. Let me repeat. Work done is equal to negative of 2.303 RT log volume final by volume initial, right? Let's substitute all the values over here. Negative 2.303, RT value just calculated as 50, log of final volume is 100, initial volume is 10. 100 by 10, so 0 get cancelled, log 10. Always log 10 value is 1. So that only the multiplication between negative 2.303 multiplied with 50 minus 2.303 into 50, the value will be negative 115.15. This is the value of work done. Work done, if known, it's very simple to convert into heat absorbed. Heat is denoted with the Q. Always heat absorbed is equal to negative sign of W. Already W value is given with the negative sign and the negative multiplied with negative, so that Q will become positive value of 115.15 because W is equal to negative 115.15. Q is equal to negative W. Hence, it will become Q is equal to 115.15. The correct answer will be option number A. For question number 5, option number A will be the correct answer. Let's move on to last question of the session. This is given from the periodic trends. The right order of ionization potential of lithium, beryllium, boron, and carbon, right? 4 elements are provided. We have to go for ionization potential. In general, ionization potentials in a group, main group, from top to bottom gradually decreases. If you move from left to right, the ionization potential values gradually increases, because left to right in the period, the size of the atom gradually decreases. That's the reason why ionization potential values are increased, because smaller the size, greater will be the ionization potential. So that the correct order must be, least will be for lithium, followed by beryllium, followed by boron, followed by carbon. This should be the order, but there is a certain change in its order. Lithium followed by boron, followed by beryllium and carbon is given. Let's see why this is the order in order to predict the ionization potential. The reason is carbon, beryllium, boron, lithium, gradually ionization potential values are decreasing, because beryllium, the electronic configuration is 1s to 2s2. Boron electronic configuration is 1s to 2s2 2p1. What is ionization potential? Amount of energy required to remove the electron from the gaseous atom, right? Let me repeat. Amount of energy required in order to remove the electron from the gaseous atom. here, in order to remove the electron from this completely filled system, it's very difficult, so that we have to expend a lot of energy. But in case of boron atom, only one electron is there in its valency shell. It's easily replaced. Whenever this electron removed, it will be converted into completely filled, so that least energy is accorded for boron when compared to beryllium. Beryllium is a completely filled, so that more stable, higher the value of its ionization enthalpy. That is the reason why highest is given for carbon, and next followed with the beryllium, and next with the boron, and the least is accorded for lithium. This is the way we can explain the ionization enthalpy periodic trends in a given period. Actually, it must be carbon, boron, beryllium, lithium. Rather, it will be slightly jumped, slightly swiped, carbon, beryllium, boron, and lithium. The reason for the shifting of these two atom position is being explained with the completely filled electronic configuration of beryllium, which is more stable to remove the electron, so that it contains a higher value over boron. By this, we completed the entire series of questions which were covered in the previous year examinations. And I'm requesting you to complete, like the channel, comment over there if anything which is mostly interesting for you, that topic you can comment over. Share this channel with the aspirants who are preparing for the examination seriously, and subscribe the channel in order to receive the updates, whatever uploaded every day. And thank you very much for your patient listening. Thank you, one and all.